we're going to move on to Ken Touryan.
Okay, thank you. My topic is future of wind power, onshore and offshore. My emphasis is going to be offshore because that's the newest entry and probably is going to be the major breakthrough and use of wind power. As of last year, it was 600 gigawatts worldwide, 34% from China. A gigawatt, like 600 gigawatt is 1,000 megawatt fossil fuel power plants. So it's significant. And just aside, wind has been mentioned 7 times in the scriptures as a metaphor of the Holy Spirit. With that background, let's just go to the first slide. Of the 600 gigawatts, 100 is US. It shows the almost exponential growth in the use of wind turbines as clean energy source. And that's where we are now. In the following slide, I'll show you the vision that Department of Energy has. Okay, the vision is wind energy could supply 20% of the US electrical demand by 2030. If you look at the lower left, it's right now 10%. In fact, it is 10% in Colorado, our wind farms. But that's the vision toward which we're going, and it's accelerating so fast. I am sure we're going to even beat that to 2030. On the next slide, we have the first offshore wind farm in United States. The offshore is much more advanced in China than here. This is the very first one, which has been operating for 2 years. It is 5 6-megawatt turbines that provide enough power for 16,000 Rhode Island homes. This is in Rhode Island, and I'm going to show you what parts of the coastlines are best for wind farms. The next one that's being formed is being designed is in Maryland, the Delaware border, which will be 15 to 30 wind turbines, and it's just ongoing. Okay, here is the very heart of the very problem of wind farms in the ocean or in the sea. On the left-hand side, it shows you installed capacities of various countries. US isn't in there because we have only one so far. The fixed bottom is very simple. It's the floating that is the challenge. And there are 3 different types of floating systems, and I will come to that. So far, 27,000 megawatts is installed in the fixed bottom, 82 megawatts only on the floating, and I'll describe to you a little more detail those 3 floating techniques. Next slide, we will show the coastlines. There are quite a few coastlines throughout the world where you can go up to 60 meters. You don't go beyond that, it's too expensive. So unfortunately, 80% of offshore wind is past 60 meters, but there is enough that the floating systems can provide energy, especially by the time at 2024. Incidentally, there's 57,000 turbines in the United States, but 90% of them, or 95%, are really onshore. Let's go to the next one. And here we will see the coastline for the United States. Notice that the northeast and the northwest are places where the wind is steady and high enough to make it cost effective. The key is 7 meters per second for wind turbine average, and then consistent wind that does not change much, and that only offshore turbines can meet that criteria. And then there's some in the south. The problem is you don't want to put wind farms where you can have typhoons or you can have gigantic windstorms. It happens every now and then, but hopefully it will not be where you have a hurricane. So it's very important to keep that in mind. All right, next slide. The very heart of the wind turbine is the blade. The lower one shows the 1980 blade. That was an airfoil. Okay, that has revolutionized now. And we have a very lightweight systems specifically for wind turbines. They're 90% lighter than the airfoil systems were. They're very interesting design features, which I don't have time to discuss, but I'll just mention a few things. In the Q&A, we can find out. The tip shape is tiny, and it's made like that it minimizes noise, for example. The design, the shape is specially done to reduce the torque of the blade, which in turn affects the generators inside the turbine nacelle. This is one single 100 is the longest turbine blade that has been made, and it's all in form of carbon fiber reinforced epoxy. It is unfortunately, because it is a plastic related, it is not recyclable. The most recent breakthrough has come, and it is made up of vacuum assisted transforming of thermoplastic composites, which can be done in sections, which will be and then fused together. Fused welding and adhesives are used. They just tested it, and it looks good. And that's going to make the blade recyclable. There's a lot more information that I can give, but let's leave that for Q&A. Next slide is the heart of the installation. There are three types. The spar, which achieves stability through ballast installed below the main buoyancy tank. The next one is semi-submersible, achieves static stability by distributing the buoyancy widely at the water plane. And then the most difficult one is the tension leg platform, which is used for 60-meter depths. It gives static stability. It's a mooring line that is used, and that mooring line really is one of synthetic mooring lines at the end of which there are chains, and of course it is anchored into at the ground. And it also allowed a certain amount of movement because the catenary is 4 times longer than the depth. It is called watch circle. A certain amount of watch circle is involved. These are the three systems that are being used now in wind farms and will be using in the future. In the next slide, we'll talk about there's been a very interesting knowledge transfer, from the oil and gas, offshore oil and gas rigs to the wind turbine, but it's limited because the wind turbine is top heavy and you have little more different problems than the oil and gas system. Other than anchoring them, there's enough difference there, but it was a good start. Next slide, I think we'll be looking at costs, which is very important. The turbine makes up only 24.3% of the total cost for a floating wind project. The blue side, you see, it's also 26%. That is one of the biggest areas where cost can be lowered. That's where the installation is, the repairs are, moving the thing back and forth, and so on. That's where the biggest savings can be obtained as we learn more about how to install these in the sea, in the ocean. Next one. Oh, I'm going to skip this. This is a very interesting platform NREL developed to help plan how you get a DC system, which is the output of a wind turbine, and connect it quickly to the grid. It's quite a technology to plan that. But let me skip that. Maybe we can recover that in the Q&A. Floating operations and maintenance obviously is very important. If it is small repairs, as you see here, a tugboat can come, and then there is a lift that goes up and down in which small changes can be made. Some of these turbines are hollow, and you have an elevator in that, but that's expensive. On the right-hand side, the major repairs, of course, you have a tugboat that have to come and a crane that will take off primarily the blades and also maybe the generators if something goes wrong, and bring it to shore. So that's where, this is where we have some of the interesting, more exciting problems. In fact, I would suggest if you really want to know how they install these things and repair, go to internet and here you'll see in some of the turbine manufacturers have a video for you to watch how they put this together. Let's see. Okay, when you erect these things, if it is less than 6 megawatts, it is done offshore, and then carried by towed into place. If it is higher than that, then you need a special platform which the Chinese have developed. It is called Sea Installer. It's a wide flat plate. It's anchored all the way down to 60 meters, upon which you put all the pieces of the turbine and erect it. First, you erect the tower in 3 sections. Then you put the nacelle. Then the last thing is where you put the blades. Usually 2 cranes are used to do the job. What is interesting, folks, is that when you have waves, 5 to 6 feet strong waves, and 10 feet or 15 feet per second winds, they still can install this in 24 hours. It's amazing to watch how much of a science they have made out of this to minimize the cost of putting these giant turbines in wind farms. And the bigger is important. I think in the next slide, we'll see the direction it is going. At first, the cost, as you notice, it has to come from $200 per megawatt hour. It has to go down to 5. It is almost there. In fact, this whole curve has moved leftward as more and more improvements are being made. So much so that there is no more need for subsidies for these turbines. It's really getting there now, and it's a wide open field now for the use of it. In fact, it is estimated that by 2030 or 40, 1/3 of the entire electric need of the globe can be supplied by offshore wind turbines. It's an immense number, but it's very much within reach, it looks like. In the next slide, I think we show that the turbines, technology improvements, lower risk, and so on. Look how it has evolved.
2-minute warning.
How much?
2 minutes.
2 minutes. Okay, I'm just about done. The very small ones at 75 kilowatts, and now we're talking of 10 megawatt unit turbines. Look at the largest airplane and the size of these turbines. The bigger they are, the cheaper it is to operate as a farm, but also the more difficult it is to install. But that's the direction things are going. Fewer installation, larger turbines are very important. No hard limits to the size of the turbine at this point. And next one is the advantages and the heart of what I have prepared. Advantages of offshore. So windmills can be built that are larger and taller than their onshore counterparts. They tend to be far out at sea, thus less intrusive to neighboring countries. Typically, out at sea, there is much higher wind. It's steady, higher than 7 meters per second, steady year-round. Wind farms have a relatively negative impact on the environment. Next slide. Oh, there is no physical, let me get that off. There are no physical obstacles. That's what's great about having a smooth ocean or a sea with wind turbines. Disadvantages offshore. The biggest disadvantage of an offshore is its cost compared to onshore because it's easier. The effect of offshore wind farms on marine life and bird migration has not been determined yet. Especially bird migrations should be very carefully considered when a large. Some of these wind farms are 150 turbines. The Chinese have one with 150 turbines. And incidentally, because they're intermittent, the large size uses the large size averaging thing. So you don't have a constant interruption because of wind. Okay, the disadvantage of offshore wind is the biggest disadvantage is, of course, cost. the last one is very tall wind turbines actually enter the wind domains. One is micro scale, one is macro scale, and the wind patterns are very different. And the most exciting part for me is that this requires aero, hydro, servo, elastic system, and it's exceedingly hard to model. This is why entire departments now are devoted to wind turbines. Next one is onshore, and we'll finish with that. Onshore is, advantage of onshore is that cheap, it's low cost. Next one is distances between turbines can be made shorter, thus saving the voltage drop. Wind turbines is very quick install. You can do it in half a day, even the big ones. Advantages on disadvantages, they're perceived as eyesores, not in my background type thing. They don't produce energy year-round because of poor wind speed and physical blockages, and so on. And wind turbines create noise, causing noise pollution. The next one is the list of manufacturers. The biggest are Siemens, Gamesa, Vestas, GE, and so on. And there are 3 or 4 just Chinese developers. The last one, I think, is give you an idea of how gigantic these things can be. This is a nacelle, only the nacelle made of fiberglass with the area where the blades go is forged metal. And look at the number of people involved and the size of this big, I call it the big mama. And that's a fascinating thing to install these things. The last one I think shows the references. There are not very many references, but there are some here and they're available for you. I will stop here because really what I'm presenting is a 1-hour presentation with 40 slides. It's such a complicated system, but I had to really shorten everything to 15 minutes to at least get you an idea. Okay?
Why don't we take some questions then? I see, Jack, you have your hand raised.
Yes, I can't resist. Ken, as you know, the Western states are in a mega drought, which has every indication of being a recurring phenomenon. And
right.
We're out of water in California for agriculture, for example, not to mention our leisure. And it occurs to me that an offshore wind platform to desalinate water might just be a unique solution. It's going to be very hard to put desalination plants on our seacoast because it's considered such a precious visual stimulation. Are there platforms big enough to put a large-scale desalination plant out to sea?
Yeah, the answer is yes, because these wind farms, the bigger they get, the production or the assembly of the systems are on the shore. In other words, the factories, the companies are moving onshore. So that's where you can, and there's enough room there to put desalination plants. And it's a very good idea to use electricity from wind turbines to do desalination.
Not only that, you don't have to worry about the brine waste because it can be dissolved in the ocean.
True.
If you desalinate on shore, you get this brine waste in large quantities you don't know what to do with. Okay, thank you.
Good idea, Jack.
I see Ronald Myers has a question. Would you like to ask your question?
Yes. How does the reliability of these compare to, say, a fossil fuel plant? And in terms of amount of how long the energy can be supplied, and with the increasing portion of the power supply, when will wind intermittency and energy storage issues become important?
There will be no need for storage. This is why the wind farms should be bigger than 50 or 100 units. The law of averages takes care of it. When one goes off, the others don't. And also, they're trying to tie farms together. When one farm goes down, the other picks up. That's one. The life is supposed to be between 20 and 30 years for these before you disassemble. And then, of course, the whole thing can be can be recycled, except for the blades, but they will be soon when they do start this new technique of attaching things together. Yeah.
All right, we have time for one more super quick question, Paul.
Ken, what's happening up in New England now regarding the eyesore factor for these coastal wind turbines?
There will always be people bitching about eyesores. I don't know. Because it is much better to be offshore than onshore. I mean, whatever you do, people are going to complain, find something to do. I don't know where it is now. There have been some legal cases and so on. But for 2 years, the one in Rhode Island is working very, very well with the 6 turbines. And let's see what happens when they put together the 30-unit one between Maryland and Delaware. But it's a point. It's always not in my backyard, right?
Right.
All right. Well, thank you very much. Let's give a round of a hand to all of our presenters and hope to see you guys in future sessions.